Hi everyone, I'm Nawaf Ahmed from RK23 and this is the video presentation for mini project electrical machine design. We are from group 28 and this mini project is about design and evaluate a 24 slot and 2-pole PM brushless motor. Brushless DC motors are receiving attention recently. They are extremely reliable and weightless than other machines of comparable power outputs. They are perfect for high-speed application. The objective of this project is to design an internal rotor of 24 slot and 2-pole PM brushless DC motor. Using general radial flux concept, the design was refined. AutoCAD is used to sketch the half rotor and half stator motor. Analysis software is used to build geometry of motor and calculate basic design parameter. And then this design is taken into Maxwell 2D environment to further analyze it. This is the half rotor and half stator AutoCAD sketch. This is half rotor and this is the half stator. This is the R shaft and this is the RSO and this is the RSI. And this is the parameter value that given for this project. And this is the result that we get from our calculation. As you can see, WTB, WSY, WTT, WTE, RSB, RT, and RSO, RSI, R shaft, RM, and RR.
Hi, my name is Fawaz Ahmed Ali Al-Sabi, RK23. So basically this is winding layout selection. This figure shows that we have 3-phase motor and between each phase is 120 degrees. We have phase A, B and C and each phase got 8 slots because we are having 24 slots overall. So each phase will take part of it, which is 8 slots per phase. Then we have the if vectors, so after we calculate the angle, it's 15 degrees between each slot. Between slots and from slots to slot, it's 15 degrees. And then we divide the if, basically it's 24 vectors based on the slots actually. And we also have the S distribution from S1 to S24. This is double layout winding, so we can see clearly that we have a positive and negative polarity from each item here. And because of the B is combined with B and every letter is combined to each other, so we have the same colors in ANSYS drawing. This is the MMF vector for each coil. So as we can see, 24 slots, 15 degrees between each slot, and we have 24 vectors. The phase A will start from 0 angle, and the phase B will take place at 120, which is F9, and F17 will indicate the phase C. The ANSYS simulation shows the vector line and flux line here. And we can see clearly that the vector lines show that the joint of poles has the most critical path, which is the red color. And the value here is actually 2.4 as the highest amount of the value, and the negative of the same value is the blue one. For the flux line, we have the same value actually, and it shows the same effect, which is between the poles. We have 2 poles actually, and we can see clearly that the critical value is only appear between the 2 poles. This is the magnetic field distribution in the motor. This scale shows the Tesla, the magnetic field density, which is from 0.02 until 1.6, which is the critical value. And we just arrived to the critical value a bit in the middle, which is the rotor, and between the 2 poles. Next is the flux density of the motor during open circuit. The interaction between north pole and south pole is very high, as it shows the critical value in here, and this circuit or this motor model shows the combination between vector line, flux line, and magnetic field distribution.
Thanks, my friend. My name is Abdullah Saeed. I'm going to explain the graphs. First graph is mid-air gap, radial flux density. VR, this is the rotor position. As shown in this graph, agreed value or the peak value of VR is 1.125 Tesla, and the other side is negative 1.125 Tesla. Second graph is of BT with the rotor position. As shown, the peak value of BT is 0.49, which is much similar than the VR value. Graph of cogging torque with the angle. The highest cogging torque from the graph is 0.0068 Newton meter. Cogging electric motor torque, as shown, is torque due to the contact between the rotor's permanent magnet and the stator slots. The torque of the cogging varies with the angle of radiation. This graph for back EMF is mid degree. The graph shows a peak voltage value from negative 34 to 34 volt. The back EMF is generated by stator permanent magnet, and the higher armature's rotation rate, the higher the back EMF relays until is equal the voltage applied. In the conclusion, the slot and pole number of motor are significant affect the whole rotor characteristics. The design of 24 slot 2-pole is overlapping, and the PLDC has been optimally completed using ANSYS software.